Hi, welcome to this video, which is going to be looking at how we write formulae for substances in chemistry. So this is just a very basic introduction. What I'm going to be going through and using today is basically things off what I call the anion and cation sheet. So if you're one of my students, you should be quite familiar with the anion and cation sheet. I'm going to put it up now so you can see it. So you could always pause it if you want and take a screenshot of this, or maybe print it out if you want. But that's what I always use. If you've got a bit more understanding about how to use the periodic table and using the groups and oxidation numbers from the periodic table, you can use that to help get your charges off of atoms. But what I really suggest you do is, if you can, use the anion and cation sheet. That pretty much covers the ones you need to look at to begin with. So what I'm going to do is just write the formula for a bunch of different chemical compounds, okay, and show you how we work out the write the formula pretty easily. So I'm just going to start off with something like sodium carbonate. Okay, so sodium carbonate, if you're using the anion and cation sheet, if you have a look, you'll find sodium and you'll find it's got a 1+ charge. So anytime we're trying to write these out, okay, we write out the symbol, okay, and we put the charge in. Now, as in maths with chemistry, we don't write the 1. So if there's nothing written out the front here, all right, that means it's actually a 1 there, all right? So, but normally we don't write it. So you'll just see something like Na+. If you're finding the carbonate, all right, if you find the carbonate over there, you'll find CO3 is carbonate. When we have an ATE on the end, that means it's combined with oxygen. So carbonate is a carbon combined with oxygen, and the charge on that is a 2-. Now, the way that we write the formulae for these is we use what I call the crossover technique. So if you rewrite these two symbols next to each other, Na, and then you have CO3 like this, you do the crossover. So up here, we've got a 2. That 2 is going to come down here and go on that side of the sodium. So one of the important first rules you need to understand is when you are writing the formula, you don't put any symbols, nothing out the front. Okay, that's for when you're balancing equations. When you're writing the formula, the numbers always go down the bottom as what we call subscripts. These are charges, these are superscript, they're up the top, and then the number of atoms goes down the bottom. So when we cross over, we take the number from up the top down to the bottom, and we cross it over to the other element. Up here, if you remember, we actually had a 1. Okay, there was a 1 there. I'll actually put that back in just so you can show where I'm going with this. And that 1 there, that number, that crosses over to the other side down here to be a 1. Now, as in maths, we don't write 1x in maths, we just write x. So that 1 there actually doesn't have any impact on the formula. So what we've got for our formula for sodium carbonate is Na2CO3. And we've just done that by crossing over the charge from the top, bringing it down the bottom. And that's our formula. So I'm going to show you a couple more. The next one I'm going to show you is slightly different. So this time I'm going to show you something called calcium oxide. Okay, so if you look at the anions and cations sheet, you will find that calcium, the symbol Ca, it's in group 2 on the periodic table, so it has a 2+ charge. And that's where I said if you know the groups, you can kind of use them a little bit to help you out with the charge. But if you have a look on the anion and cation sheet, it says 2+ on there, so we put our 2+ charge on there. And oxide is oxygen by itself. So oxygen is there. It's in group 6, which also means it has a 2- charge, or if you're using the sheet, you can see 2-. Now, the really good thing about this one is you can actually cancel these numbers out, because a 2+ and a 2- actually cancel. But if you follow through and do your crossover technique like we did before, you'll see why they cancel. So we get Ca and O, so you write them next to each other, and then you take the numbers. So the 2 here will come down to this side, so Ca2, and the 2 from this side will come over to here. So we're going to get Ca2O2. One of the important rules in writing formulas that you always cancel down if you can. So if you find atoms that have the same number or a same common denominator, then you can cancel them down. So 2 and 2 will both cancel down to 1 and 1. We don't write ones, so the formula for calcium oxide is CaO. So I wanted to show you that because I wanted to go through the principle of cancelling down, but I also wanted to talk about the fact of that if you have the same numbers here, 2 plus and 2 minus, you can just cancel them out. So if it was 1 plus and 1 minus or 3 plus and 3 minus, you can cancel out straight away and get to your formula. All right, I'm going to show you a couple more. The next one I'm going to look at is magnesium phosphate. Okay, so if you're using the anion and cation sheet, you'll see that magnesium, symbol Mg, has a 2 plus charge, and phosphate is what's called a polyatomic ion, same as the carbonate that we looked at before. So it's a phosphorus with oxygen. It's actually PO4, so that means why it's called polyatomic, many atoms, and the charge on it is 3 minus. So if we want to combine these together to get the formula for magnesium phosphate, again, write them next to each other with just a little bit of gap for the numbers. And then we do our crossover technique. So the 3 up here, that crosses over here and comes down to be Mg3. Okay? The 2 over here, this comes over to form a 2 here. Now, if we just wrote this out as is, we would have Mg3PO42. Now, we don't need 42 phosphates in here. We actually need just the 2. So one of the rules, the other rule that comes in when you're writing formulae, is if you have a polyatomic ion, so that's an ion which has 2 capital letters in it, such as PO4, you need to put brackets around it. So we're actually going to rewrite this as Mg3, but to make sure that we understand that we need 2 of the phosphates, we're going to put the phosphate in bracket here, and then we put the 2 in. We only do that when you've got multiple capital letters that the number here applies to, okay? So because we had PO4 and we brought a number over, we put brackets around it, and this is the formula for magnesium phosphate. All right, I'm going to show you one more. The final one I'm going to show you is involving sometimes where you have transition metals which can have different charges, and they're what we call different oxidation states, okay? So I'm going to look at this one, which is tin, all right, and I'm going to write tin there, and then what you'll sometimes see in brackets is the Roman numerals, so IV, okay, which means 4. I'm going to look at tin carbonate, because we've done carbonate before, so I just want to have a look at how it combines with the tin, all right? So if you look at tin, all right, the chemical symbol for tin is SN, and the 4 here, the IV, is actually telling you what the charge of the ion is. So this is actually a 4 plus. So tin 4 there is SN4 plus. The carbonate is CO3 with a 2 minus on it. Okay, so what we're going to do is, again, we're going to do our crossovers. So put them next to each other here, SN and CO3, and we're going to cross them over. So starting with the 2 here, we're going to cross the 2 down to here to become SN2. All right, and the 4 from here, we're going to cross this over to this side to become a 4. So we're going to be able to now incorporate a couple of the different rules that we were looking at here. So because we have, all right, the CO3, a polyatomic ion here, 2 capitals, we're going to put brackets around that. So we're going to get SN2 CO3 with a 4. But what we can also do is that other rule I talked about, which is where we cancel down the atoms, because we've got 2 and 4 here, both have a multiple of 2, so we can actually cancel it down again to SN CO3 2. So cancelling the 2 out, 2 goes into 2 once, so there's a 1 down here, 2 goes into 2 goes into 4 2 times, so this is our final formula for tin carbonate. All right, hope this has made sense. Practice makes perfect with these guys. I just suggest you start finding names of different compounds or elements, not elements, sorry. 3, 2, 1. Okay, so I suggest that you just do some practice on this. What you can do is just write down a name, pick something on the anion side, pick something on the cation side, and just start practicing writing the formulae for these, or just Google names of common chemicals. See if you can work out what the formula is using the anion cation sheet. The anion cation sheet will not cover everything you need, okay? So sometimes you will need to go to this next step of working out from the periodic table what the charge is going to be, but it's a really good starting point. All right, if you've got any questions, just ask, but as always, hope this has been helpful. Thanks, guys.